I'll show you the lousy soldering I do. Okay, so we got wire coming in here, wire coming in, going through these push button switches. And they're going to this, which I've heat shrunk. I like put some various pieces of heat shrink round. Right, so we've got the CNC Shield, one of these going to CNC Shield. Now 5 volts on mine, it only seems to be coming out about 3.1 on the CNC Shield, but there's 2 markings. I'll show you some images of that now. Anyway, when I've measured them, even on the one that says it has 5 volts and 3 volts marked, it's still, they're both coming out about 3.3 volts, give or take a, tenth of a volt or whatever it is. Anyway, so we've got positive coming around here, coming along this line and going to the ground down here. So that's like one loop of positive going to ground. I didn't have any 1K resistors, which are the sort of ones that are recommended, well, suggested in a way, but I did have some 2.2K. So put 2 in parallel, see there, one there, one there, one here, one here, one here, one here. So because they're in parallel, that halves the ohmage, so far as I understand it. That's about 1.1K. It's near enough, in my view. Well, it works. So I've got one for each switch, because I've got 2 switches, plus another like 1. So you want 3 1K resistors, that's the suggested, and you want a 1 mega ohm resistor coming down here, which goes to the abort pin on the CNC Shield, which is the same, it's AO on the Arduino. It's the same basic pin that goes through the shield to the Arduino to the AO pin. Also, that this end of this 1 mega ohm resistor here goes to the switches, basically up here, and goes like that. So if this switch is closed, say that one's closed, well, let's say they're all open, then where's the signal going to go? Nowhere. Well, down this 1 mega ohm resistor, okay. So there's a bit of current going to come down here and go to the pin, but that should be reasonably stable as long as it's got reasonably good quality resistors, so to speak, presumably. But when this switch is closed, the current's going to go through this 1K, let's call these 1K resistors because that's what they're equivalent to in near enough. 1K resistor coming down here, going through here, as well as going through the 1 mega ohm resistor. So it's going through 2 resistance there, and that'll drop this resistance a little bit. I'm not going to work that out, somebody else can work that out if they want, it doesn't matter. But that's just going through, let's say that's basically going through one lot of resistance, and we can measure that on the AO abort pin on the CNC. We can measure it on the Arduino. Okay, AO. Well, you don't have to use the abort pin, you can use one of the other analog inputs, so they're analogs. Now if this switch is closed, this one's open, and it's going to go through 2 lots of 1k resistors round. Okay, it's going to share the load out with this 1 mega ohm and down and signal the abort pin. Now what if two are closed, then I believe that basically it's going to act like these two resistors, one here, are going to act in parallel, and that's going to half the resistance of those two. So we're going to get about 500 ohms. This is my understanding. That's with both switches closed. So we can measure that on the Arduino. Might spell that wrong. But that's the basic thing that's in this Heath Robinson sort of Frankenstein thing here. So I've got two red wires going to the switches. 1, 2, and two white wires going to the switches. 1, 2, coming from this side, coming from the resistors. I have stuck some sticky labels on here to remind me which wire is which. Okay, I'll get this put on the board and I'll so there's a CNC Shield on top of an Arduino under there. Where the Arduino is powered by that buck converter on the right, 12 volts coming in, going to the buck converter, but also going to the top of the shield up here, 12 volts, but that is split up to a 5 volt signal going to the Arduino Uno below. Okay, here's all the pins. Why they put pins on, why didn't they put sockets on, I don't know, because on the Arduino the sockets like these, similar to these for the steppers, drivers, they're all sockets, but on here they're nearly all pins. Okay, so you might see there can I get that in to focus, I don't know. And we've got 3 volts and a 5 volt there, and over on this side we've got 5 volts, but those output 3.1, about 3.3 I think it's supposed to be, with a 5 volt input which I've got. So I'll wire it up and then we'll see if it works anywhere near. Well, I'll give you a demo program. So just for this test, just to show you, I've got this yellow wire that's going to the abort pin, which is the 4th pin up from that side where on the side where the power's coming in. Okay, on the inside row, abort. That's just a name to give to it, I suppose. Then I've got a ground pin. All this row, so far as I know, I assume they're all connected together on this left hand row, as we're looking at it in the video, are all ground. So this one's going to the resistor in this heat shrink, as I mentioned, is ground. And I've got, this is marked 5 volts, the other side of the cable, going to the 5 volt pin here. But remember that for me, the 5 volt pin only supplied, well, let's call it 3.3 volts. Right, I'm just going to run a test program here. Right, I've got this big code running here. As you can see by the timestamps on the left, you can put timestamps on or not over here by clicking the buttons. I put the timestamps on because it's hard to see. That's moving sometimes if you don't. I'm going to press the left hand button. So I've got this I haven't got the LEDs wired up or anything, just the buttons. Left button pressed, okay. Let go. No buttons pressed. Press the right hand button. Right button pressed. Let go. No buttons pressed. Both buttons together, and it says both buttons pressed. Okay, let go, and no buttons pressed. So that's basically it. I can press both buttons and it comes back with both buttons. Well, the message that both buttons are pressed. Let go of the right hand button, leaves the left hand button on. Left hand button pressed. I'll let go of it a bit there. Right hand button, both buttons. Keep the right hand button pressed. Let go of the left one. Right hand button is pressed, yeah. And it's almost, you know, it doesn't matter what combination I sort of do, I don't think. Obviously, if you have more of these, like resistance chains, I'm going to call it a chain. Remember that you do want the last one here as well, like one extra than the number you're going to use. You can have more switches basically, but that's going to be a bit more difficult for the Arduino to struggle with, in my opinion, between one resistance and another resistance. Now I believe I have read up somewhere, I don't know how true it is, that the total amount of resistance you can have, well, for the signal anyway, is 10k, that's 10 kilo ohms. Okay. I've posted this code up to GitHub. There's a link there. I'll put a link down below and a bit of description here about what it sort of does. This is the very basic code. So I have a serial there for displaying on the screen. Okay. Pin mode, set that to input. I'm not sure if that's needed actually. Anyway, I do a state first to keep track of what's happening, sort of thing, whether the button's being pressed or not. Analog return value, so this reads the analog pin, which is set up there, A0 on the Arduino, or if you, like me, using the CNC Shield on top, it's the abort pin. Okay, and basically then the return value from the analog port, if you want to call it that, the analog pin, is sort of compared. If it's within these ranges, it just prints to the screen that both buttons have been pressed. It says it's button's been pressed through, and likewise between those values, left button's pressed. Between these values, right button's pressed. I've got that wrong. So if it's between these values, which I've got, you can adjust these in the code. So that gives a bit of variation. If the resistance change 1k, well 1.1k, I'm using 2 in parallel because that's all I had handy. 1.1k is near enough. It might vary a bit depending on temperature, so that gives a bit of a range there. So that's both buttons. This is left button, this is right button, and if the state there hasn't been set as true, then no buttons have been pressed basically. So I'll let you have a look at this code here. Yeah, that's all the code there. If you get that noise, it's because I'm doing something in the background. I do have a delay here, that's more so I can see what messages are coming on the screen. Obviously you can take that delay out. I think it does take a little bit of few microseconds to read the analog port pin, so to speak, here. I'm unsure about that, and whether you want things happening exactly, and I do mean precisely the same time. I can't swear to that. You have to remember things like how, you know, the distance the electric is travelling. Alright, in this case it's a very short distance, but there are other factors. Okay, so that's the code.